Hey everyone, hi, this is Phaneesh. Thanks for the opportunity to present things here at the DevCon 2022. A quick introduction about myself here. So I currently work at Koo as CTO, and I've been in the technology, product and data science space for the last 18-20 years, spanning across various organizations like Redbus, Sprint and Lucent. And at Koo, I've been there for the last 10 months, and we are building the next social platform connecting the various users of India across multiple languages. Happy to share the platform here and discuss a few interesting things that we are doing at Koo in the NLP and the language space. So before we get into the actual problem statement of NLP and how we are doing, a few things just to understand from a use case that we are actually trying to solve. So Koo as a company or a product, we are trying to build the core language NLP piece, stitching across all the different languages that India speak here. So as we are all aware of, right, there are hundreds of languages and thousands of dialects being spoken in India. And from an internet market space, we are the second largest region here, and almost 1.3 billion folks, correct? And more than 500 million internet users, and almost 900 million internet users going to come by 2024. And if you look at the spectrum of these users, almost 75 to 80% of these people do not speak English. Though they might be aware of English as a language, but they might not be fully conversant, fully understanding what is happening. They don't have access to some of these different tools and other things that we as metro users or tier 1, tier 2 city users are privy to. So this is the problem space where Koo has kind of come into the picture, providing the thoughts and opinions platform to these specific users. And when we started looking at the space, the overall social apps that we looked at, right, had not been built with this audience in mind. That was one of the big gap that we saw. And when people are using these products, the language translations, transliterations, and all the various things around the native or the vernac content were very much missing in the ecosystem. And slowly when we started taking one peel of the other, not just the language, but even the onboarding experience, how do you even educate the people about the product, what they need to do, what they should not do. There were a lot of these other things also that had to be built as a part of the overall system. And that also goes with the saying that having a very immersive keyboard, vernacular keyboard, these things make the job easier for the users. But how do we ensure we can bring in all these people together and ensure there's no barrier in language? That is the main problem area that we are solving. And when we looked at this problems statement from a technology perspective, right, we felt that it was multidimensional. On one dimension, we had to understand how do we give the users a very quick understanding of the overall content in their language of choice. But Koo being a thoughts and opinions platform, we also wanted to provide certain depth with which translation, transliteration, understanding these particular content from a sentiment, etc., can be done across languages. So this is the space we operate in, and we'll get into some core details about how we solve this technically and discuss about some of the approaches we have. These are the different use cases that we are working at Koo in the NLP space. At the core of it is what we call as MLK, or the multilingual Koo. It involves a lot of translation and to some extent transliteration. Then we also need to understand topics across different languages. I'll get to that. Then search itself is a very critical problem for vernacular users. Then understanding or extracting the NER, named entity recognizer, on the content is another very interesting problem that we are delved into. And there's a lot of spam classification that happens because of the various content that we get. And this again comes across multiple languages. So these are the places where NLP is being put to use at Koo, and we'll go into a few details now. Just to give a understanding of how actually the product works, right? So this slide helps you to understand what are some of the things that we are making the life of a creator very simple. So as you see in this slide, when a creator comes to our platform to post his content or Koo, what we call, we are giving that person different languages on which he can actually translate. So he or she might be very conversant in English or Hindi, but let's say he wants to reach out to a much wider audience that he wants to get into who speak different other languages. We provide this auto translation in some cases where we have built our own systems, and in some cases we leverage third-party providers. With the help of this, as a user, he's able to push it across different languages, and at the same time, people in different languages and in different states are able to consume this content in the language of their choice. So at the net, we are able to connect someone in Maharashtra who wants to put his thoughts in Marathi to someone in Kolkata who wants to understand that particular content in Bengali. And this is where the transliteration, and ensuring these topics kind of connect together happens with some of our models that we have built. The other important place is the onboarding funnel, where we have given a lot of importance. What happens in onboarding is the people are coming to our platform for the first time, and we'd really like to understand more about the users at that point of time. So for example, some set of folks might be interested in entertainment, sports, news, media, whereas few folks might be interested in politics and multiple other categories that we have. Now, based on the kind of interests they have, we want to showcase other different profiles they can follow on the platform, and also by following they're able to kind of connect to the right kind of content they want to actually provide their thoughts and opinion, as well as be immersive in that. So onboarding is a very critical piece where we actually ensure we understand every user very clearly, and at the same time we have labeled our data, we have trained a lot of our models to do the right recommendation as well. Now, the language that comes into picture here is people when they onboard, some of them are Hindi speaking, some of them are Bengali, Kannada, Telugu, Tamil, whatever we want to look at, right? So during this entire space, we have to ensure that transliteration happens really well. So someone who is reading, so though they might identify by the person's face, in some cases it is quite obvious, but in some cases for some of the topics, what do we translate, what do we transliterate, it has its own journey. So we have put in some efforts to ensure those things happen well. So I'm going to go a bit deep into NLP here and kind of walk you through the different thoughts that went into our mind when we were actually building the NLP platform for Koo. At a broad level, if you look at it, the main problem we are trying to solve is how do we ensure we are able to identify certain topics in a content, right? Now the content is in native language. Now when we want to understand that particular content in that native language, we need to have some kind of a labeled data for that. So for example, I might be saying in English, looking forward to the T20 World Cup in Australia, right? So it talks about cricket, it talks about Australia as a country or a continent, and it also tells that I might be interested in sports and cricket. These are some things that I'm able to derive out of this particular statement, correct? Now imagine I speak the same content in other languages, right? And that is coming as text. So how efficient are those models to ensure that I'm capturing the same set of sentiments, same kind of NER tags, I understand that topics really well. That is where the complexity comes in, for which we need to build various things. So obviously from a process, if you look at it, in the few years back, supervised learning was something that a lot of them started using. There are some good advantages and disadvantages of supervised learning. You get a very good labeled data set for that particular language or for that domain. And based on the amount of training data that you have and the corpus that you have and the level at which it has been trained, fairly we are able to get a lot of accuracy and good results, good quality results. Now, for us, that is not fine, because we also need to build associations across languages, because translation happens and transliteration happens. Because someone might be consuming a content that was primarily written in a different language. It has to get translated. From the translated data, we need to extract the topics, and those topics have to be relevant for the end users. So if we have to interchange based on the model that was being developed using supervised learning to a different language, the accuracy was pretty average. So that model did not scale well. So those are some important things to consider when you are building your NLP cases. So in a nutshell, supervised learning really works well when you're building for a specific domain. You have chatbots, virtual assistants, where there's a more structured business flow, and it's fairly easy to do. But when there is across domains, and in our case across languages, accuracy is something that to watch out for. As a gradual progression from supervised, a lot of the research went into unsupervised learning. Unsupervised learning has a lot of advantages over supervised. One primarily is you don't need so much of label data for different languages, right? Or for that particular domain. Even though it is able to learn a lot of things on its own, understand the different patterns, also look at some context, it auto learns. There's a cost in terms of computation that comes into picture. So this is the one of the cons of unsupervised learning. And though we felt, let's try out some basic things in the unsupervised space, training for models was always a challenge, and that always took long period of time and high computation and resources. So though the problem, one of the problem it solved was in terms of not requiring to have label data, the problem got offset into computation and lower accuracy. And in fact, we did some work where we actually compared supervised and unsupervised techniques very quickly for some of our data set. In some specific cases, supervised learning actually gave better results over unsupervised. And ROI was not that very great when we actually look at unsupervised learning techniques. So from 2017 to 2018, there was a lot of research that happened in the NLP world, and 2019-20 is the one where transfer learning really kicked off, right? So transfer learning is something that really ensured NLP can be used more strongly for a lot of newer use cases like what Koo is doing, and at the same time it is giving us that leverage where we don't have to really worry from a ROI, etc. So we'll discuss this a bit in depth now. So there were a lot of deep learning models that were actually trained for certain domain A or language A. Now what transfer learning does that is the model that is already trained can be used for model B or for a language B or for a domain B as well. That is the big advantage we get. And on top of the existing model, you can build few more layers to get the desired accuracy. So in the computation, in the computer vision problem statement, right? This is where transfer learning actually started getting a lot of steam, and that kind of propagated into the NLP space as well. Some of the RNN and the LSTM models that were built and which became very popular in the computer vision, a lot of those work has gone in that direction, and few things have been adopted for NLP as well. One of the core interesting or the most powerful attribute of transfer learning, apart from the language, apart from the different domain where you can transfer, is also there is information that we can actually get in the transfer learning, which is with some context also at times, which helps. And at the same time, the way you try to provide that data in or the data set in one domain, how it can be used for the other domain is something that the model automatically picks out and helps in understanding how some patterns which are not easily recognizable by us can be used to transfer the data to the second model. If you also look at it from a con, right, for transfer learning, this again takes a decent amount of time in terms of training that particular model. Every time it is using one token or one word which it absorbs, and it's hard to actually parallelize these operations, though some work has gone in that direction. This is where some of the bottlenecks happen in the transfer learning. But what transfer learning opened for the NLP world is how you can transfer the knowledge that you already have learned on one domain to be used in a different domain. Now, this is where we also from Koo as a problem statement, right? The language corpus that we had for English, Hindi was quite high because that's where a lot of the users speak, a lot of the content has been created, and a lot of the more structured labeled data is something that we have. Now, if you want to build some models for, let's say, a Kannada or Hindi, or Kannada or a Malayalam or a Telugu, one is you go in a traditional way, you keep labeling the data for all these things and keep building that. But some of the things that you have already learned in Hindi and English, can that be made use in these new languages or the other things that we want to build? So that's where that thought process happens, right? And that's our thought process as well, and that's how we are moving. And from the transfer learning, the next evolution that happened in NLP was the concept of transformers, right? So Google published a paper in 2019, if I'm not wrong, about BERT, right? And I think a lot of the people who follow the NLP space are pretty much aware of what BERT is. And in fact, at Koo, we use the BERT model as well in some capacity. BERT has been quite phenomenal in terms of what it does. And to understand BERT in this thing, it might not be the right time or the duration, but I'll go into a few specific thought processes that went in building our model on top of BERT system, right? So in the transformer space, BERT, GPT-2 and GPT-3 are the existing high-end models that are out there. These models are all pre-trained models with very large amount of data, almost more than 175 million different data points they have used to build their existing things. And they've also shown that with these specific models, the amount of time to actually train is very, very less. In fact, even without training, the accuracy of certain things can be much higher. That is what these models have proven, correct? So now, if there is a language which is totally new, but we want to make use of certain use cases like topic extraction using BERT model, right? It's a very useful and a perfect solution because one, we don't have to necessarily start hunting for all the keywords in that particular languages, and at the same time we already have an existing model, and there are a lot of use cases built on top of it, and BERT as a system has showcased that is able to connect different things. In BERT, what actually happens is the way in which the model is constructed and the way in which the intelligence is actually embedded within itself is primarily because it is bidirectional. So if any sentence is given or a set of tokens is given, it establishes the context both in single direction as well as in the reverse direction, and that intelligence is kind of embedded into its system. And because of this particular nature where it is directional in both ways, the kind of context that gets set in is much more powerful and much more accurate in different dimensions of vectors per se. And this is the advantage that we are using. This is the advantage the BERT model provides, which we are harnessing for our topic extraction in Koo. And also to accelerate, if we have to train a couple of more layers on top of BERT, right? We also can make use of the power of GPU. With the GPU acceleration, we are able to train anything at a much or run our experiments at a much quicker time. Time to market or time to take it to production is reduced. So these are other obvious advantages that we get. And when it is consuming the raw data, the system, right, we don't have to train that for some different kinds of use cases, unlike supervised learning and other strategies. So all these different use cases can be easily extracted out, like text classification, in some cases the text generation that you might see in autosuggest, and again NER part of it, where we want to extract the core system, the core points there, right? So in this slide, I'm showcasing topics, how topics as a feature has been developed at Koo. Why are topics essential is the first important scenario, right? So what I mentioned in the beginning, right, we want to understand people's area of interests, correct? So they might be interested in cricket, sports, politics, and they might also be interested to understand or follow some specific personalities, where someone is talking about them or someone is actually there on our platform, correct? So topics becomes manifold and at different hierarchies as well. So it's very important to understand that grid system as to how topics, interests, all these things come together and help in giving a better recommendation to the user. Recommendation is one machine learning problem, but before we even go to the recommendation system, how do we even build that topics as a structured knowledge graph in Koo's database, right? That is the problem statement that NLP solves here. So we get content or Koos from different languages, right? So some are talking about, let's say, the information about, I'll take a cricket as an example again. Some people are talking about the IPL that is going to start, and IPL has different franchises. There might be local people talking in their native languages. But if you think about it from a zooming out, all of them are talking about IPL. People are talking about cricket, and people are talking about sports. So this information is something that, as a topic, we extract with the help of the models. And secondly, what we also do is whatever we have learned in one language, we transfer that to other language as well, so that time reduces and the system auto learns if we want to enable newer languages as we move forward. So obviously there's some amount of fine tuning that needs to happen to make it available, but almost 70-80% or more than 80-85% of our work in terms of enabling another language is reduced. So this is the essence where if a match between Bangalore versus Chennai is happening, people are able to talk in different languages, but as a person who is in Bangalore who is speaking Kannada, they might not understand what a person might be talking in Tamil. But if you are able to connect these two users, because we know that they're talking about this language or talking about this particular topic, which is Bangalore versus Chennai IPL, there's a lot more engagement, lot more reactions, lot more things that happen on our platform, and language is no longer the barrier for people to provide their thoughts, right? So that's how we are solving this. Now to go over this at a very broad level, to classify as politics, entertainment, we use shallow classifiers, n-grams. Then to go to the named entities, where we need a slightly more sharper topics. For example, we want to know if some UP elections are happening in some specific regions, there's something happened in some place in Bangalore, or some interesting work is happening in IIT Madras or IIT Mumbai, whatever could be these regions, right? It's important to understand these sharper topics very clearly. So for that, there is a pre-trained data set and the model that we use to kind of ensure all these are automatically extracted, and enrichment of these keeps happening. Human assigned labels are also very critical in the earlier phase of our NLP journey, because we want to ensure the accuracy is very strong. If the accuracy is very strong, that's when people do understand what is happening in the system, and that's how the engagement levels also go forward. In some specific shop category, right? So for example, we are interested in talking about, let's say, the climate change happening in some places, right? Now, climate change is a very interesting term because people might be talking in general about the weather, but people also might be talking about, okay, environment is getting affected because of pollution. A lot of other specific keywords come into picture. Now, to get that understanding that people are talking about climate change and associate all the content that we have with climate change as a topic becomes a huge problem statement to solve. So that's where zero-shot classification models come into picture, where we train on certain thoughts and move it forward. The other place where we are also doing some research is in NLI, natural language inference, where the concept is a bit different. You have a hypothesis, you have a statement, and based on true or false, we kind of decipher which is doing well. So these models are also kind of becoming quite handy in the recent past. If you have to go into more, if you want to go deep into in some models, we want to concentrate on accuracy, right? Because we don't want to lose on the accuracy there. Let's say there are some elections happening in some places or some sports activity happening in some regions, right? To do any kind of extraction on these regions and or to do any kind of extraction of content from these regions for these topics, the accuracy is very critical. We have certain features in our product where it's called a nearby, where in and around your city what is happening, and Koo users come and discuss about in and around the city. So in these places again, this is very critical where we get the accuracy right. So here we use some pre-trained embedding vectors. That is a concept we use, which helps in building these things. And finally, you need a platform to kind of run these different experiments, work on these different models, build these things, train these things, monitor, etc. So this is where we are using Uber's open source Ludwig for our model training, and we also use Bento ML in some places. So this is the kind of structure in which some of these use cases have been built. Yeah, in this slide, I'm going to talk about model fine-tuning as a concept. I think model fine-tuning is very critical in the journey of taking or productionizing things, because this is where it actually makes a lot of difference in terms of accuracy, and it adds a lot more value to the business. In this slide, we'll take an example like how you can make use of a pre-trained BERT model and how you can fine-tune it, right? So in Koo's use case, when we took the pre-trained BERT model and used it out of the box, it gave us some accuracy which was decent enough. Now, let's say I want to improve the accuracy for Kannada as a language for topic extraction, right? So one technique to do that is you freeze the layers of the BERT model that is already pre-trained, and you experiment with different data sets, right? And see how the weights get adjusted on the freezed layers. And the output of this, which gives a good accuracy for your data set, and is something that you can monitor, measure, look at the model drift and other parameters, and productionize it. Now, to carry out these different experiments for these different data sets is the art of how you label the data, what kind of training data you use, and how you actually take it forward. So that is one. Now, as a next iteration, let's say you're still not happy with whatever experiments you carried out with all the different data sets that you did. How else can we improve the pre-trained BERT model, right? So a couple of extensions that the model provides is you can add your own few extra layers on top of the BERT pre-trained model that is already available. So I have my Kannada language translation or topic extraction, whatever use case I'm trying to solve. I build few layers which are quite important, I feel, because that's how in the last iteration my accuracy did not go well with those cases. these new layers that I've added can now be added on top of the pre-trained BERT model, where the older or the standard layers are frozen, and these new layers are now used, and together we train the model on this, again carrying out these different data set experiments. So when we do that, this new few layers that I've added along with the existing model will definitely give a better accuracy. And we have seen this happening in some of our experiments, where you take a pre-trained model, build few layers, and keep adapting it or keep improving it based on the data that you get. And to kind of monitor, measure, it's all done in a good way, so that you are able to really get to the very specific understanding that these are the important training data that I need to use to fine tune the model. So there's some pattern that there's some pattern that gets established. To get all these different things executed in a very seamless fashion with greater operational efficiency, MLOps is what is very critical for an organization's success as well. Without MLOps, what happens is all these things still do happen, but there are a lot of gray areas where things can go lost. Some data set is lost. We don't have accurate measurement of the model accuracy or the model drift as and when it has moved forward. And there's a lot of repeatable tasks that takes a huge amount of bandwidth in both on the engineering as well as on the data scientists. So MLOps has been used in various companies, and it's still an evolving field. And this is something that we again have started taking a very conscious call on. So in this slide, I'm going to give you pointers as to how NLP, MLOps have all been put to use, and they have all come together to solve the bigger use case. So typically when ML scientists or engineers start off, they're all in their Jupyter notebooks, pulling out different data sets, running their different strategies and models. And once they get into a good state where they feel this is a decent system based on whatever they have been training, how do they productionize? How do they modularize their code? How do I keep my code in a way where different parts in the Jupyter notebook or the different cells can be productionized? Few cells can be used for testing. Few cells can be used to pull the data, which is more of an ETL. Few cells I can use it for running a certain model based on the data set. So you can label all those things and keep it in a good module, and you can reuse these modules across notebooks as well. So to enable this interchangeable notebooks, code, modules, and all these things, NBDev is quite popular and quite handy. So that is something that I would highly encourage people to use it. Coming to the operational piece, there's a lot of no-code or zero-code platforms that are out there to fasten the labeling process, tagging, as well as updating certain labels and tags. So Label Studio is an open source one, which is quite good, and also in terms of its capacity to do all the MLOps and tagging is quite decent enough. And this is also being heavily used as we speak in various companies, and at Koo as well we use this. There are a lot of repeatable tasks when you're running different training set, right? So you want to run a training set on some specific data set 1, data set 2, data set 3, and also at certain times when a training is, let's say, happening for a decent period of time, let's say 3 hours or 4 hours or much more than that, you don't want any inaccuracies in your model because it's time lost and computation lost. So you also build certain test cases to ensure all these things correctly are passed before the training starts. And you also want the model training to kind of trigger when it encounters certain data sets, and you can enable and flex it as you move forward. So to do these kind of different things which become a part and parcel of engineer or a scientist, using GitLab actions or the runners are very powerful. They help you to define these specific workflows in a very codified way, and you're able to understand and iterate on that and keep improving the efficiency. So MLOps as a system or a process or as a term, whatever you want to call that, is something that for organizations who really want to build a strong data science ML teams, they need to embrace MLOps very aggressively. And once all these things come together, where you are building some really cutting edge models, having a well-disciplined MLOps team who following the process, the more effort goes in actual problem solving, and all these things become more secondary in nature. And this is how at Koo we are thriving to kind of break the language barrier for the vernacular content. Thank you. Signing off here.